session number 11, and the topic we are covering is educational session, fabrication, welding and corrosion.
A group of people have decided on this topic mainly because don't be carried away with all these exhibition. Don't be carried away that stainless steel is the ultimate metal of construction for all your needs, both industry and also domestic, right from your injection tubes to big oil and gas pipes. So you can make these items out of stainless steel, but everything is not rosy with stainless steel. Stainless steel, in order to get the full benefit of stainless steel, you must know everything about stainless steel. That is why this session is called education session. And plus, there are so many pitfalls, so many unexpected problems, or which are not normally cashed upon. So there are hidden properties of stainless steel which you must know thoroughly in order to get the full benefit of stainless steel. So that is why the word fabrication, welding and corrosion has been chosen as a topic for this session, and mainly because all said and done, you must have seen different pipes and different equipments. All this, if they are not made properly, it is not sufficient only to make a melt of 304 SS or 316 SS composition. It's easier to make melt rather as compared to make a plate or pipe or tube or vessel out of it. So you can see a lot of container vessels. It's a lot of fabrication involved, plate rolling, making the tolerance, and make sure it would withstand the pressure inside. That is why the mechanical property, the fabrication comes into the important. And then finally, as my friend Parthasarathi was mentioning, welding is there everywhere. So you cannot avoid welding. So you ultimately have to join everything. So the welding, main problems of use of stainless steel occurs as a result of welding. So the welding means you are creating a molten metal. That molten metal must compare with the base metal with respect to composition, and then because it is molten metal, the structure is different, so it behaves different compared to the base metal. So all this will create a problem to you, and whether it is a cooking utensil or whether it's a needle pipe. Our injection needles are made out of thin strips. The thin strips are formed into a tube, and then there is a fine weld joint. You cannot imagine that you are using a welded tube. It is called capillary tube. And so you can imagine the kind of quality expected out of small injection tube. On the other hand, the same quality is expected in a huge pipeline where it is oil and gas being supplied. So, and here any defect problem on a capillary tube, your health is affected. Whereas there, your whole nation is affected. If there is a huge fire, like it has happened a few years back in the Andhra Godavari pipeline. So the quality is extremely important. So the whole purpose, probably the organizers, Virgo, have decided to keep this at the end of the conference because you have to go with a caution. So you have to go with a caution how to handle at your end the stainless steel. So with this aspect, we are going to have about 1.5 hour session, and there is another. I have my friends here. I am basically a metallurgist with interest on corrosion. And when you say interest on corrosion, you cannot go away without doing anything about stainless steel. Stainless steel and corrosion resistance go hand in hand. So corrosion can be solved by painting, by the so-called cathodic protection, by adding inhibitors, but all this will work only at a certain level. When you expect a heat transfer, the painting will not work. So there are reasons why you go for stainless steel. So that is, and that aspect is usually appreciated by metallurgists. So I am basically a metallurgist, and then I am looking under corrosion. My friend here, Parthsarathy, he is basically a mechanical engineer, and he knew right from his education the welding is an important subject. So when I can make only a recommendation, I cannot implement that weld joint, whereas Parthsarathy will come in hand with help me in implementing what I am going to say. So finally the implement. So Parthsarathy is expert in welding. He has worked with the biggest company in India, Larsen & Toubro, for several years, and then he is contributing to an Austrian company, and so he will be telling us about the most advances in welding. And corrosion is an interface between a metal and environment. Environment means chemistry, the chemistry of the environment. A dry environment will not lead to corrosion. That is why we have a dehumidifier, the dry place. Your concrete, your reinforcement concrete corrodes only outside, not inside the building. So because there it is moisture. So not only moisture, there are so many chemical elements involved. Sulfuric acid, caustic, urea, ammonia, all these are all chemistry. So without chemistry, you cannot attack corrosion. That is why we have Dr. Tanki here. He's a very expert in the chemical aspects of corrosion. He has put in a long years of experience in Gujarat State Fertilizer, GSFC, correct? Yeah, Gujarat State Fertilizer Company. And fertilizer is one product where you cannot make the fertilizer without any appreciation of corrosion. Whether it's a pipeline, whether it's a urea reactor, or whether it's an ammonia distillation column, or even ammonia handling, ammonia storage vessel, there are so many corrosion problems. So he is going to contribute, and he has come across quite a lot of problems which related to welding and fabrication, and he'll share with experience to us. So I was told by the organizers, quite a lot of, I don't see quite a lot, but some engineering students are here. So you will definitely know that we are going to talk something which you are not in the books. So there are something practical knowledge. Weld-related corrosion failures, I will talk in terms of case studies. But then before that, I will just briefly mention, Dr. Tanki will expand some of our items. The factors influencing corrosion of weldments, weldment design, most important, it should flush with the parent metal. Welding is after all a joint. If there is any problem with design, you will enter into corrosion problems on that weak point. The welding practice is very, very important, and the man who is doing the welding, he need not be an educated man, but he must be thorough with that process of how to make a welding practice. Moisture contamination is very, very important. The moisture contains hydrogen, and this hydrogen, if the electrodes are not properly dried, this hydrogen will enter into the base metal. Not only base metal, weld metal. During welding, water may evaporate, water may dissociate, and then hydrogen will enter. And hydrogen, I don't know how many chemists are here with the background. Hydrogen is the smallest element in the periodic table. So the hydrogen will enter, just like sugar enters water, hydrogen will enter into the metal, and will lead to this problem, hydrogen cracking and moisture contamination. So your well joint, your electrode, everything must be absolutely pure without any dryness, without any wetness. The oxide film and scale, that is what we call rusting. So all the rust has to be removed if it is a steel. And if it is a non-other, some aluminum or copper welding, we call oxide film. The rust is the word used only for steel. So oxide film and scale, weld, slag and spatter. During welding, the moisture, the molten metal just evaporate, not only evaporate, it just separates. I'm sure Parthsarthi will know better. Very big companies, they have a separate workshop for carbon steel, separate workshop for stainless steel. Am I correct? Yeah, so you don't mix stainless steel welding to carbon steel welding. You should not mix. You should have a separate, this kind of a slag and splatter, as soon as the hot slag comes and sits on a stainless steel surface, that particular location is no more stainless steel. And you'll get into corrosion problem there. And incomplete weld penetration or fusion. If you are welding say about 12 mm thick or 10 mm thick pipe, how do you make sure the welding is okay at the bottom? The weld seems to be okay at the top, but at the bottom. So that's why incomplete weld preparation. If the weld joint is not there, there is a small crevice between the two plates to be welded, and there the water will go and stay stagnant and lead to a localized corrosion. The whole purpose of choosing the stainless steel is lost. You don't want corrosion, so you have chosen stainless steel, but unfortunately you have not taken the precaution. So it started corroding. So incomplete weld preparation. Porosity. The moment the molten metal solidifies, if there is any gas is there, it will become pore. So that means it is not a stronger. Like a chalk piece, it will break. Like a sponge, it will act as a sponge, not as a solid metal. The porosity, cracks and crevices. If your plate is not properly fabricated, those cracks and crevices will lead to unusual, unwanted corrosion problem. High residual stresses. When you bring two plates together and welded, the plates, originally it is free. And then you are bringing them and putting them together by fusion. The moment you cut off the fusion, the plate will not in the same position. It will go off, fly off. That means there is a certain amount of residual stress. Like end of the day, I don't know how fresh you are in the morning at 9:30, but right now you are loaded with so much in the brain and so much for eyes. You are under stress. Your residual stress. That residual stress is there on the plate also. So it won't show us. So that will lead to a problem. Corrosion has got a soft corner to occur only at residual area, with the residual stress area. That is why the plates are all annealed. The moment you draw a plate from 10 mm to 2 mm, you are putting a lot of work on it. So that work has to be annealed. So annealing means you remove the high residual stress. Improper choice of filler metal. So many electrodes are there. I don't want to mention the company. There are big companies specializing only in electrodes. So you have to choose a particular electrode. There are 101. How many of you have gone in the shop? Every pavilion you will see 51 grades are mentioned. 100 grades are mentioned stainless steel. For every stainless steel combination, there is a specific electrode, specific filler metal, specific wire. So that you have to choose. If you are wrong in choosing, you will end up in a problem. And the final surface finish. Stainless steel means like a mirror. So that finish is also important. A rough surface is more corrosive than a smooth surface. So you must polish. That is why we call it our household utensils are always beautifully polished. They always used to be questioned. Chloride is very bad for stainless steel. But in our household, we are dumping so much of salt, sambar, rasam, and all that on stainless steel. Why it is not corroding? Because you are continuously washing. If you allow something to remain there, and you will see rusting there. So because of continuous, the same process, same stainless steel plate, if you put in seawater and remain stagnant, you'll get a problem. So these are the kind of things you must be very careful in using stainless steel. And metallurgical factors, and being a metallurgy, welding is a part of metallurgy, and so there are specific metallurgical factors affecting corrosion of weld assemblies, micro segregation. And in the previous session, Dr. Kamachi Mudali was mentioning what is the purpose of, what is the effect of small intermetallic components or different phases. So micro segregation within the stainless steel itself, precipitation of secondary phases. I don't want to go through in detail because there's a lot of metallurgy involved in all these words. Recrystallization, HAC means heat affected zone. So these are all metallurgy, but it's very, very important. And to get the full benefit of stainless steel and to get the full benefit of weld joints. Here are the typical weld defects are shown here, and you can see the two plates are welded there. Two plates are welded, and it's a arrow. Yeah. Okay, two plates are welded, and you can imagine so many things there. They are all the heat tint. There is an angle welded at the bottom, and because of that, there is a heat layer on the other side of the plate. So that will be area for corrosion, and you can see the paint is not properly removed, and you can see small hatched area very close to the weld joint. That is called a heat affected zone. So these are the areas where corrosion will take place. So you must be very, very careful not to have these defects. Yeah. And you can see you can see a couple of companies I saw. They are very specializing in removing these tints. This is oxide film. You can see a brownish film. When I say stainless steel, it should be very smooth. That smoothness is not there, and that film protects the so-called chromium oxide, which is very important for corrosion resistance, and so that has to be removed. You will see a couple of companies, they specialize in pickling solutions. I don't want to name the company, but those different formulations, chemical formulations are used to remove these weld memories. The structure is affected because of the heat, and so that is if you leave it like that, you will see corrosion. I have seen so many domestic heater joints, our geyser tank starts corroding only at the weld joint because it is not properly finished, properly served. It is only polished outside, not inside. So I have seen quite a lot of corrosion problems inside the water tank. So this is the problem there. So this is a little more metallurgy. After welding, grains are affected. I don't want to go through this at the end of the day. It won't get into the word intergranular corrosion is high metallurgy. People are getting PhD topics only on that word. so at the end of the day, probably at 6:30 in the morning, I can teach you on this, but not 6:30 in the evening. Okay, it's a lot of metallurgy, but it's very, very important. So this is how the thickness is lost. And you can see part of the thickness is corroded by looking at the dark lines. Those are the dark lines like mud pattern. Those are the dark lines where corrosion has occurred. Whereas on the top surface, you don't see that much of corrosion. So if you are going to a company, you bring an ultrasonic wall thickness detector, and it won't show any loss of thickness, but but corrosion is there. So this is a very important. It's a localized corrosion. It is not a wall thickness reduction. It is a very, very localized corrosion without showing any NDT value for thickness reduction. So all these can occur near about a weld joint. That is the reason I mentioned this. You can see stress corrosion cracking. You can see absolutely no corrosion. no wall thickness reduction, but you can see on the right hand side, fine cracks are developed. These are called stress corrosion cracks. The corrosion happened at a localized place near a weld joint and residual stress. So all these are important. So by a very careful welding and very careful annealing after welding, it is called solution annealing. Like if you put a sugar in water, it dissolves. Similarly, you can put chromium in steel, it will dissolve. Carbon in steel, it will dissolve. So that is why it is called solution annealing, and that will remove this problem. This problem is very, very dangerous than the ordinary corrosion. Ordinary corrosion is what we call rusting. So the rusting is something junk pakata, no? So that is something you can rub off, but you cannot rub off this. So this is a very dangerous form of localized corrosion. So with this background, I'll just spend another 5-10 minutes and hand over to my friends here presentation. I'll just make one typical case study. I don't know how many of you from the chemical process industry, and you'll be able to appreciate the problem. This talks about a 14-inch diameter, 8 mm thick stainless steel pipeline, which suddenly failed after a couple of months service. It was meant for 25 years of service. Only after a couple of months of service it failed. And this is from a fertilizer plant. You can see urea is made out of ammonia and CO2 and NH3 combination. So you have to produce, you have to remove the CO2. That's why we talk about green nowadays. You have to remove CO2 and send it to the air and balance NH3. Again, you react with CO2 to produce urea. So one particular location, in normal practice, Dr. Tanki will be expert on this. Normal practice, most of the ammonia plant is carbon steel metallurgy, whereas urea plant is stainless steel metallurgy, urea plant. So, and this happened in the urea plant circuit. And that is a particular location. It is called the vacuum pre-concentrated section. We don't go into detail. And that particular line showed in red color suddenly burst. Even the plant was designed very high pressure. Fortunately, it was an automatic plant. Nobody was injured, just like Bhopal. Just like Bhopal, suddenly a pipe burst and killing so many people. But here, nobody injured. But you can look at the stainless steel pipe. And this is a little detail. And you can see at the bottom, it's a 316 stainless steel. If you go through all the pavilion, 90% of the shops talk about 316 L stainless steel. And it is a 14-inch diameter and 8 mm thickness. And it is made out of ASTM A358. All these are all standardized. And you can see the huge construction, a typical chemical construction. Just to give you the size of the plant, you can see a man standing there. So you know what type of plant you are dealing with, a huge plant. And any failure on that plant, you cannot tolerate. And that is the place where you can see the small fractures occurred. And now I'm going to blow it up. And that's like a fish mouth open. And then fortunately nobody was standing there. It's a high pressure, high temperature urea solution suddenly burst. And then if you are there, you cannot even tolerate a few seconds. And fortunately nobody was there, computerized the plant. And it has happened in the night shift. And nobody has, but you can look at it, it's almost close to the weld joint. You can see the weld joint there. And so you can see now you can see close by. And it has happened at the weld joint. See, the parent metal is okay. It is not thinned down. It has not become like a balloon and then burst. It's a purely, the weld is something wrong with the weld. And you can, this we call it a dead body. A pipe is a dead body. There's no use of that. So we are post-mortem doctors. So it is very useful for us. not for urea makers. So we will make a PhD thesis out of it. So why it has happened, how to prevent it. So that is the PhD thesis. So it's very useful for us, not for the company. It is a dead body. If I have not told them anything, the next day it would have gone to scrapyard. That means the whole science and technology has gone to the scrapyard. Okay, so that is so we went through all the details, and we went through and then measured the thicknesses, and you can see the pipe. Yeah, I'll slowly coming. Yeah, see, you can see the weld is very good. The whole weld is very good. You can see the parent metal and the weld joint, the weld itself, but it just gave way at the joint. So, and that is the surface. So the weld is not properly matching with the parent metal. There is a gaps are there. The gaps we call it crevice. We call it crevice. If you keep your fingers very tight, the air gap, that is called crevice. So when that crevice, solution can go inside and start eating away the parent metal. So that crevice corrosion has happened here, and that is cross section of the ID and the cross section of the middle of the fracture surface. And radiography and ultrasonic showed definitely there is a partition between the weld metal and the parent metal, but that has been assumed as so it is not going to make any problem. So the third party inspector has passed the pipe. And the diagnosis, incomplete fusion of the parent metal and weld metal on the inside surface over a distance. That formed a longitudinal crevice corrosion. That's a form of corrosion. We don't want to go into the detail. There are several forms of corrosion, out of which crevice corrosion over a period of time, which is only for a few months. And gradual reduction of the load-bearing wall thickness, that particular location, it has become a balloon. So it is sudden rupture. So this should have been avoided by proper radiographic inspection, should be carried out during procurement of the pipe. The radiography inspection is to check the soundness of the weld. And more the pipe may be qualified, but not the weld joint. Thank you.
We get into the topic of fabrication, welding and corrosion. Already Dr. Ilember Perumal has set the standards for this session as such. And right from morning I was sitting in this room and I was listening to various lectures, starting from Mr. L.C. Trivedi, who was from the railways. And he was talking about various components like wagons, like coaches, like various other parts of the rolling stock. And I would like to tell that all these are all not possible provided if there is no welding available. So basically, I would proudly say that Fronius is the name of the company what I represent. We are actually doing the welding of joining of the entire metro, which is actually manufactured by Alstom. And also we are also doing the manufacturing of the coaches which are running in Pune, which is once again of aluminum alloy. So we are into that. And we are also making a lot of nation building exercises, like we are a part of Chandrayaan 3 in terms of making the entire components which are there for the launch vehicle Mark 3. So Fronius is one company which is actually manufacturing welding equipments and using this for the various joining process. So the first part of wagons was also covered by me. Second, Dr. Kamachi Mudali was talking about the defense manufacturing, and also there was one more, Dr. Gunasegar from the Naval Materials Research Lab. We are also associated with all the various research labs in India, and we are also providing support for the nuclear submarines. We are welding the nuclear submarines, and also we are a part of the projects like Scorpion and many other leading projects in India. And also the next part, the previous session, they were talking about something from the chemical industry, the breweries and things like that, where stainless steel plays a major role. So I am also there in these industries also. So I would take you through some of the experiments what we have done, and I would like to share with you certain important aspects of welding in stainless steel particularly. So moving on, the objectives will be comparison of various types of base materials which are available. And I will also talk to you some of the innovative welding processes like TIG process, something called as cycle TIG. I will also like to talk to you about a dynamic wire process in TIG welding. Then MIG welding process also, which is nothing but the gas metal arc welding process, which is the world-renowned cold metal transfer process, which also I would like to touch upon. And there is another process which is used for joining, which is called as the plasma arc welding process. And I would also like to slightly touch upon with one slide on additive manufacturing, which is going to be the important aspect in the days to come, which is also being done with the welding process. And last but not the least, I will touch upon the robotic welding process and also the mechanized welding solutions what we have. So stainless steel, I would not talk much about stainless steel because right from morning we have been discussing about that. And Dr. Ile Perumal also already prepared this session by telling that stainless steel is stainless because of the chrome oxide which is there on the surface. So what is the problem with welding? We'll discuss about that. But before that, I would like to tell that there are various metals available which are actually possible with welding process like aluminum alloys, the regular carbon steels. There are something called coated steels which are called as zinc coated or galvanized steels. And we also have stainless steel. And there are certain nickel based alloys, and we also have copper alloys. So I would like to tell that out of all these alloys, the stainless steel is weldable with all the processes. Like I would say TIG welding, plasma welding, or even MIG welding, it is very much possible with the all welding processes. So I would like to go to the next type of welding, wherein you can see a new process name, which is called cycle TIG, which is being used for stainless steel, which has been displayed today also in our pavilion. And I would like to show that cycle TIG is nothing but is an interval TIG welding, which uses a polarity which is called as the direct current electrode negative polarity. And what is the advantage of this cycle TIG? So you can see here, you will be able to, our moderator was explaining about the weld puddle, how you are able to control the weld puddle. This can be very easily controlled with this process. And we can have a combination of pulsing in TIG and also a function called as the tacking. And we also have to have a very, very controlled heat input on the stainless steels, particularly with respect to the austenitic grade of stainless steels, which are there here 300 series. So here we can use this process for that. And there is another aspect which is called as the temper colors, which is nothing but the oxidation. Because of that, there is various color change in the stainless steel. When it comes to the aesthetic part, it is very important. So cycle TIG, I would like to show you that how it looks to you when it is being used in stainless steel. So here I take an example of a 1.5 mm thick material and a 4 mm thick material, where you can see this is what is the look and feel of the cycle TIG when I weld a 1.5 mm fillet weld. I don't know how many of you are from welding field, but still this joint is called as a fillet joint, where you will be able to weld even a 1.5 mm thickness without any change in the color of the weld seam. So here you can understand one thing, the heat affected zone is very, very controlled. So coming to once again to a higher thickness, a 4 mm, you will be able to see the seam like this. So this looks like a very uniform. Maybe whoever doesn't understand welding also can appreciate by looking at the aesthetics of the weld seam. So this is what is possible with the cycle TIG when it comes to the kind of this fillet joint. Then coming to the other types of joints, which is actually the corner joint, which is there shown here, and then there is an edge joint. So here you can see the seam, weld seam, which is very, very uniform. These are all done by a manual welding process. And this is actually was displayed for the last 3 days at our stall. My colleague is also there here who has done the welding also. And this is very much possible with the stainless steel. So moving forward, so you can see a cycle TIG process, which is once again done on a 1.4301, which is nothing but the 304 grade of a stainless steel, a 1 mm thick with a very low amperage and very low heat input. That is very important. somebody who can appreciate welding can see something which is called as a kilojoules per centimeter, which is 0.778 kilojoules per centimeter in this particular 1 mm thick component. So this is very much possible with a special kind of a gas nozzle which is called as a champagne gas nozzle, which is actually giving a very high amount of the gas flow with the help of a special gas lens. And I will be able to weld even a 1 mm thick material which I have shown here without any kind of an undulation or distortion. So these are all the technologies which are being used for the areas where the weld aesthetics is going to play an important role. So coming to further suppose I want to build on an edge, like you can see some sawtooth kind of a formation in this particular picture. I can show you how I will be able to control the heat input and I will be able to weld on this particular tooth points. I would request our friends to play the video so that you can at least hear. Yeah. You can see how the control is. And yeah. So those who have not seen the exact process can appreciate by looking at how a controlled heat input plays a major role at the interval welding. You can even able to have a very low heat input. So I will move on further. Yeah, this is another important aspect I would like to touch upon titanium also. As such, chromium, titanium, all these alloys have got very high affinity towards oxygen, but still I will be able to even weld a titanium alloy without any kind of a protection. So here also there is a video. Because of paucity of time, I'll switch over to the next, which is called as the TIG dynamic wire. So here what happens is in a TIG welding, normally a manual intervention of feeding the filler happens. But here, today we will be able to do even with a hand by using a separate arrangement with a separate kind of a pen. Maybe the video can give you some additional, here you can see an overhead welding is possible with the help of this kind of process in stainless steel. Can you play the video, please? Yeah. Here you can see how the welder, the technician is able to feed the wire. The wire automatically gets fed according to the movement of his hand, and TIG welding can be done, even overhead welding is also possible today. So this was not possible in the past, but due to the innovation in the technology, these kind of processes are also possible today. Yeah. So moving on further from the TIG welding to the plasma arc welding. Microplasma is one of the process where I can even weld a 0.1 mm thick. You can see some dentures, dental fixtures, some kind of bellows which are of 0.1 mm thickness. So this is also possible to weld when it comes to the, once again, this is a stainless steel which is both 304 and also with 316L. With the help of the microplasma, we have welded these kind of applications also. So moving on further, we have the soft plasma. Once again, this plasma arc welding can be used in various exhaust components, and here you can weld from 1 mm to 3 mm once again. So this is another kind of an application in stainless steel, particularly for the plasma welding. This is called as a soft plasma. Moving on further, for the high thickness, you have something called as the plasma keyhole. So here we can weld up to 10 mm thick, and the 10 mm thick materials can be welded with the help of the plasma keyhole. We create a keyhole and we move on and we will be able to do the welding. I have given certain parameters also wherein I have even gone up to 10 mm thickness. So this is what is the various kind of process what is there in the plasma. Furthermore, the gas metal arc is another process which is conventionally called as the MIG-MAG welding. So here you can see a process which is called as the cold metal transfer. So you can see this video. Can you play the video? That will give you some idea. Yeah. This is a patented process of Fronius, where there's a separate mechanism by which the wire moves forward and backward, and I will be able to even join steel to aluminum. This is the process advantage, and you can see here this particular robot is being programmed to make a kind of an additive manufacturing, that is some kind of a component from nowhere. You can build from a substrate and you can build a component with the help of this. So today, welding is not that what we see in the roadside. welding is something like we call it as from 3D to 3C. Welding was originally very dusty, dangerous and dirty, but today it has become very cool, clean and clever. So we have moved from 3D to 3C. This is what is the welding, what we are doing in the industry. So this is actually the specific patented process of Fronius, which is called as the cold metal transfer, where with the help of this, you can build, you can join, you can clad, all types of processes in one kind of a process, which is called as the cold metal transfer. Yeah. I will move on further. Yeah. So here, something called as a pulse multi-control. This is another process of GMAW, wherein you will be able to weld with the help of the robot, wherein you can actually have a kind of this seam, weld seam, which will be shown to you here now. You can see the seam, which is a modification of pulse welding. It is called as a pulse multi-control, where I'll be able to weld this kind of seams, and all the ill effects of the heat can be avoided. A welding engineer can understand the sound, and he can understand and tell that what kind of a process is going on. So here it is actually a pulse process, a modified pulse process. I would request to play the next video also, so that you can understand that how robotic welding helps in welding of stainless steel. So here an experiment what we did for L&T Ranoli, where we have done this pulse multi-control process. You can see here, I am not showing you any component because of NDA, because of certain non-disclosure agreements. This is just a kind of a fillet joint with a robot, once again stainless steel. You can see the deposit when the welding is complete. This was done at our skill center in Pune, Innovation and Skill Center, where you can see such kind of weld seams without spatters, without any kind of color change. So these are all possible. These processes are being used in the industry, wherein high productivity is required for a thicker grades of stainless steel. Furthermore, I'd like to tell you that additive manufacturing is another area where you can actually build the components from nowhere. You can take a substrate, with the help of the filler wire, you can keep on building components, and then you can machine it further. So the conventional process was the subtractive manufacturing, but today with stainless steel, you can actually make components also. You can make components like valves. There are components like landing gears. There are components like the rocket propellant tanks, which are all made out of additive manufacturing, and stainless steel is extensively being used in many areas. So furthermore, mechanized process, we have very many types of mechanized process is also possible. There is something called as a clamping bench, something called as a compact cladding. Furthermore, you want to do a mechanized welding, you can also go for a circular welding mechanism, where you can mount the component and still you will be able to do the welding with the help of these kind of features, which is actually called as the compact welding systems. So last but not the least, I would like to tell that we are also working with all the IITs and NITs across Pan-India, where we are actually able to give them the technology transfer. We can make the custom-made welding cells. These are all the various kind of oxidation issues. So here you can see the amount of the oxygen, which is always less than 20 ppm. Then you will be able to have a very good seam. That's what I want to add on the oxidation front of stainless steel, which has to be always taken care when you are doing the purging. So there are various types of purging gases. We can have argon, nitrogen, then nitrogen-hydrogen mixtures, argon mixtures. These are all used in stainless steel when you do a welding of a pipe. So conclusions, you have to choose the material in a right way. Then corrosion resistance is a very important aspect you have to check. And there are many challenges in welding, but we will be able to take care of the challenges by using the proper technique. And the trends are emerging. And above all, the safety is very, very important when you are actually doing the welding. And this also has to be considered. And with this, I conclude. And thank you.
Talk about a huge plate welding. You can see the range of application of welding. So Fronius, we are very lucky to have Fronius with us. And now we go back with the full confidence. There is somebody to suggest welding and somebody to execute the welding. Okay, right. So, thank you very much. Now we'll go to Dr. Tanki, and he will talk about the welding defects and welding caution to be exercised, particularly from his own experience.
I think it is so difficult for the students to grasp at the moment, no doubt. But I would like to make you a little fresh in this case. I am not here to find out the fault with the stainless steel, but I would like to finger out that there are certain areas, if you are not careful, stainless steel can behave notoriously. There are certain points which I will bring it to you. Are you able to listen to me, sir? It's okay? So, let us see first slide then, sir. Sorry. How it goes? Okay. So, I am trying to find out the fault with the human being rather than the machineries. First is that, as humans, making mistakes is a part of our nature. The consequences of these mistakes can vary greatly depending on the industry and the impact of the project. I hope you'll agree with me. In some cases, a project management mistake may not be as crucial, but in others, it could mean the difference between saving or losing a life. Regardless of the situation, errors can lead to wasted time, money, and most importantly, loss of trust. I'm just giving you a write-up in this one because of you will be more focused on this one. Because when I'll be talking to you only, I think your ears might be cheating me and your eyes will be over there. So I want to hanger you over here. So this is the thing which is quite attractive to my friend Shashi, such type of fabrication. Proper design, fabrication and testing of pressure vessels is essential for operational success and for avoiding issues in the field. Here is the case, sir. Why do project fail? I am using the word project because of the manufacturing or fabricating huge vessel structures. It's a project in which we are utilizing 80% of stainless steel. But why it fails? The matter is why does it fail? It is the poor. Can you read it? What is that? Discussions are not in totality. That's why. Here is the case. Stainless steel, also known as inox, corrosion resistant steel or rustless steel, is an alloy of iron that is resistant to rusting and corrosion. It contains at least 10.5% chromium and usually nickel, and may also contain other elements such as carbon to obtain the desired properties. Stainless steel's resistance to corrosion results from the chromium, which forms a passive film that can protect the material and self-heal in the presence of oxygen. I think these are the basics, but I think it will give you a good runway to fly again ahead. The alloy's properties, such as luster and resistance to corrosion, are useful in many applications. Stainless steel can be rolled into sheets, plates, bars, wires, and tubing. These can be used in cookware, cutlery, surgical instruments, major appliances, vehicles, construction material, in large buildings, industrial equipment, for example, paper mills, chemical plant, water treatment, and storage tanks and tankers for chemicals and food products. So it is a very versatile material of construction, which I am trying to say the positive aspect of it. The biological cleanability of stainless steel is superior to both aluminum and copper and comparable to glass. Its cleanability, strength, and corrosion resistance have prompted the use of stainless steel in pharmaceutical and food processing plants also. So we fell in love with the stainless steel. Okay, these are good things. But where that good things become little alarming, that we have to look into. 6 mistakes to avoid in metal fabrication. Metal fabrication is one of the oldest manufacturing processes in the world. Although it has evolved over the years, it still requires a significant amount of training and practice to master. I hope Mr. Sasi will agree in that case, no? Lot of training is required, so you are the good trainer, the reality. Today, there are various types of automated equipment, which just now we saw in the various videos which Mr. Shashi showed to us. Automated equipment used for the purpose of metal fabrication. While the metal fabricators themselves are trained and skilled, there are certain common mistakes that happen during the metal fabrication process. That is what you want to see in the micro level. Don't forget in my first slide that the man is open to the mistakes. And welders are the human being. So they are not the culprit, they are the workhorse for that case. These mistakes may escalate while dealing with high pressure and high temperature industrial applications, sometimes endangering the lives of people working. Therefore, this presentation sheds light on the mistakes that are essential to avoid during metal fabrication. Now, precautions to take during the metal fabrication to avoid common yet hazardous mistakes. The metal workers are expected to be cautious about the following factors. First, making pseudo assumptions. Metal fabrication is a mechanical process that impacts several industrial applications. The performance of any equipment will depend on its construction and reliability of the integrated parts. Every business has different specification when it comes to metal fabrication. Therefore, the metal fabricator must avoid pseudo assumptions. Instead, he should communicate with clients to understand their technical requirements, and this will help reduce manufacturing defects, honor the deadlines, offer the right quotations, and so on. Second is incorrect material usage. Although most metal fabrication facilities use cheap yet durable materials, their lack of understanding of them will be a big drawback. Hence, during the discussion phase, they must reach in consensus about the type of material to be used on the basis of the final product requirement. These are the very important points which I brought it from the experience in the literature. This is very important. Why improper material storage? The filler materials used for welding during the fabrication are susceptible to corrosion due to ferrous metal composition. As a result, the filler materials must be stored in a moisture-free place. If not stored properly, defective metal filling can occur. Binders will then be required in a high amount. Therefore, material storage has to be done cautiously. I will take a pause over here. I will just share my personal experience, say 3 years back, when 6 countries, including India, were involved in the manufacturing of a huge stainless steel heat exchangers for Qatar fertilizer, QAFCO. And that material, when it was to be installed at the time, QAFCO didn't have the time to install it. So they asked the final, please wait for few months till we get our downtime. During that time, I will not name the thing because of it is again against the certain laws. And they asked you to please store it somewhere place and we come back to you afterwards. It took about 1 year and 6 months to get the order back. I think Gse was one of our sons, those who were the final people to have the direct talk with the Qatar, this company, WAFCO. For that 6 months it came and then it was installed rightly. Having 10 years of expected service life, it failed within 2 years and 8 months. $150 million cost of that project. And Qatar being a petroleum people, they simply ask people that you pay us back the amount, whatever we have given to you. And under a lot of risks, they agreed because of they cannot afford to displease such a precious client. But then there was a tug of war between all the 6 parties: India, England, France, Germany, Austria, and Italy. So nobody was agreeing that we are not at any fault. Then it went for about, say, 5 to 6 months arguing on the telephone by having a lot of correspondence. And they could not come to any conclusion. And because all the manufacturers of the tube drawing, fabricating, welding, all were up to the top men. So they could not say anything then. Why I'm sharing this thing? Because Indian me was involved in that case, sir. They were in search of somebody, corrosion man, who might have worked in the fertilizer industry and should be there. So one fine morning, I received a phone call from France, Paris, in a very French English terminology. In the morning, there was one lady who was asking me, finding out whether I am the same Dr. Thanki or no. Then she asked me whether you can help us to resolve this problem. Really, it was a quite big thing. But at the back of the mind, when I was asked as an Indian, they were asking me amongst all these white people. Really, it's a matter of satisfaction. Then I took that challenge. Yes, let us go. I don't know what will happen. But then they told, Dr. Thanki, we will not buy you single pie. I was astonished. Why I'm working and servicing you? Okay, no, doctor. Why it happens? Okay, what are the amount we will pay you? Say 5 lakhs rupees, 10 lakhs rupees for the consultancy. But then the company, those who are joined, they are multi-millionaires. If they can purchase you, so they had to worry. If you give 10 lakhs rupees, they will give 20 lakhs rupees. They would like to therefore in their line. So they told, we will treat you like a prince. We'll take every care. In this one, improper material storage I am talking about. Highlighted. Because I was to talk, I may forget to talk to you people. Thank you, sir. So I was invited. And really it was just like our Prime Minister goes in the way he gets the respect. In our level, technocrats, I got what respect. Like the limousine car, staying in a 7-star hotel. But during all this time, all the people involved, now you might be knowing that just like for the political problems, is the international platform. Like that, for technical, some problems, Paris is the set. With international people for the arbitration, they come over there. So I went to Paris for, say, 9 days. But during that time, I was just in a custody. I was not allowed to talk with anybody. My mobile also was taken away by them. And that 3 days they had given me whatever the papers, 3,000 pages were there. I was to study all this. Then when I was in the hotel where I was putting up, my neighbor was that same people, because they should see that I am not talking with anybody. Nobody is coming to see me. Even during late evening, they will permit me to talk to my family about whereabouts. That was the stringency. But can you understand me when I am single man with all white people with very high level of technical and money power point of view. But then the third day, it was just you had a jury, just like in a court. So people will come over here with a different desk of 6 countries. 3 persons were there, over decision makers. And when I will come here, people will stand up, they will give respect, and fine. Then first discussion took place. 4th day, I also had a group discussion with them individually. But I could not find any fault. Who is wrong? Then I got worried now what to answer this one. It was a big challenge. Suddenly I could see improper material storage. Because when I was told, 1.5 years it was stored. And it was in Italy. I asked them that I would like to visit the place. On the very next day, I was flown by helicopter to Italy. And I visited that place. And as a corrosion manager, a metallurgist, whatever you say, it was struck in my mind. It was just, say, 1,000 meters away from the sea coast. And such type of things were there. And then I could see the failed components which were there already. Something were not rushed to the Qatar. And I could see the problem, where the problem is. And then the 8th day, I gave the verdict. And that verdict was very much liked by them. I told them that nobody had fault. It is we could not understand the language of nature. What language nature is speaking, we could not understand. They also were asking why it is so. Then I told them that this is the only salinity, humidity has played its role. Because 1.5 years it was exposed. And that whole salinity had reached to the level where was some stress might have done be relieved with the tube-to-tube shaped joint. Finer crack might have generated, which was installed in the plant and it was failed. So it is the improper material storage. Can you understand the importance of storage of the material? So it is giving you a very live case study to you, sir. So storage plays very important role. Fourth is improper arc striking. I think Gsse can elaborate a lot big way in this one. Arc striking is performed to produce heat for welding. However, if the arc is marked incorrectly, it might damage the metal workpiece. Thus, the welders must pull the weld tool away before the filler material itself sticks to the wrong arc location. Incorrect arc striking may lead to a high amount of material waste. Technical inflexibility. Metal fabrication is a process that involves multiple techniques. These techniques may vary depending on the application. Inflexible metal fabricators may obstruct the fabrication process. Fabrication techniques must tailor to a specific job, and workers need to be versatile. Versatile, I place a lot of importance to this one. Inefficient time scheduling. Metal fabrication is a process that really relies on factors like material, work consistency, temperature, pressure, and time. The fabrication of metal is a time-consuming activity as the filler metal and winders take time to settle on the application spot. Rushing the job without scheduling proper lead time increases the risk for accidents. The fabrication process must be properly scheduled for productive results. So these were the points I think you should keep in mind. These are some. Now this is very important. Stainless steel cleaning, care and maintenance. Only 5 minutes. I have given you extra. Okay. Okay, I will rush, sir. The attractive and hygienic surface appearance of stainless steel products cannot be regarded as completely maintenance-free. All grades and finishes of stainless steel may in fact stain, discolor or attain in adhering layer of green in normal service. To achieve maximum corrosion resistance, the surface of the stainless steel must be kept clean. This is very important. Wipe it out every day. Frequency and cost of cleaning of stainless steel is lower than for many other materials, and this will often outweigh higher acquisition cost. Good housekeeping during manufacturing. This is what we are talking about, fabrication 1. The ideal is to have workshops and machinery dedicated to only stainless steel work. But in a workshop, also processing other steel, avoid pickup from tooling used with other metals, grinding wheels, wire brushes, finishing belts, steel storage racks, contamination by grinding or welding sparks, handling equipment, adjacent carbon steel fabrication, which I could do wherever I worked as the advisor to the industries. It was my first foremost thing that they should make very specific workshop for that. Getting the best out of the stainless steel. Main issues, that importance of surface finish in determining corrosion resistance. I will not detail it, sir. I think that you will be getting later on. You can read it because time is running away. Importance of post-fabrication treatment. Apart from some specialized processes, welds in stainless steel always result in small degree of heat tint. Heat tint is essentially an oxidized surface which is a reduced corrosion resistance compared to the parent material. Therefore, the normal practice is to carry out some form of post-weld treatment to improve the corrosion resistance. Good fabrication practice always include post-weld treatment. Failure to do so can give rise to unnecessary cost of rectification later on. Third is the importance of segregating carbon and stainless steel, which many times in a small industry they do not give the budget. They don't have floor area enough, but then they suffer a lot. I will not dwell on this side. Fourth is the importance of site management. It is quite possible for everything to be done well in fabrication, only for the whole project to be spoiled by inappropriate practices on site. So what I try to say, stainless steel is not at fault. The way we handle it, it is fault. For stainless steel, it has to remember that masonry and debris cleaners may contain hydrochloric acid, sometimes called muriatic acid. If these fluids are to be used at all near stainless steel, care should be taken to protect the stainless steel surfaces. This is sometimes we miss these things. Masonry can create a lot of problem. Failure to do so will result in serious attack of the stainless steel, resulting in expensive rectification cost. Importance of choosing correct grade for the application. I will not be. 6 is the cleaning and maintenance. And 7, importance of seeking technical advice in cases of doubt. Don't be your own judgment person. If there is any doubt about the correct choice of grade, surface finish, or other aspect of prospect involving stainless steel, the advisory services can be consulted. Don't think about the cost of the consultant. It will come back to you big way. I don't know, sir. I'm just telling you, sir, when doctors are needed, when you take a hing and something in your home, and it said the better is to pay something for the doctors. Please. Because it will give you a return multi times. Corrosion stainless steel, certain specific domains, metallurgical factors, weld solidification, then the corrosion of outstanding stainless steel weldment. I just read it. The corrosion problem commonly associated with the welding of stainless steels are related to precipitation effects and chemical segregation. Dr. Perumal had allowed this one, no? These problems can be eliminated or minimized through control of base metal metallurgy, control of the welding practice, and selection of the proper filler material. This is very important point. Now this is important. This is stainless steel is very prone to this. Carbon steel is not. Right? Here is under moderately oxidizing condition, such as a pulp and paper, bleach plant, weld metal may suffer preferential pitting in alloy depleted regions. This attack is independent of any weld metal precipitation and is a consequence of microsegregation or coring in weld metal dendrites. And then the crevice corrosion is a vulnerable thing because this creates a lot of problem. Being a noble metal, it will not adjust with anything. So it creates problem. Sites can also occur at the beginning or end of weld passes, between weld passes, or under weld spatter areas. Weld spatter is most troublesome when it is loose or poorly adhered. A good example of this type of crevice corrosion is the type of physical stain shown as below. Here, crevice corrosion is a problem. Incomplete penetration, and these are the points which leads to the problem of the metal.
Thank you all. Thank you very much.